Do you know what are polynomials? It's a very important chapter in class 10th maths, and we are going to learn it starting today. Okay. So first of all, polynomial hota kya hai? So polynomial is nothing but a expression which is in terms of a variable like x or y or something. So if I write 3x square plus 5x plus 7. So this is a function in x, right? The value of this expression will change based upon different values of x, right? So that's why it's a function. Now, when I say this 6 square plus 5 plus 7, is this a polynomial? Yes, this is a polynomial because here we have the powers of x as 1 and 2. So if you see here, the power of x is 1 and here the power of x is 2. If we have another expression, let's say 2 upon root x, is this a polynomial? No, this is not a polynomial. So for polynomial, we should have powers in integers. Okay. Now, let's see what are different kinds of polynomials that we have. So we'll start with the linear polynomial. What are linear polynomials? Okay. So let's see linear polynomials first. So if I have a expression or a component which is having single power of x, like only one power of x is there. Let's say 7x plus 3. This is a linear polynomial because if you draw the graph of it based upon x, let me try to do it here. So if it is 7x plus 3, to start with 3, for x equals to 0, the value will be 3, right? And once we create a line, it will go something like this. Okay, so that's why it's a linear polynomial. I mean, once you draw the graph of this polynomial based upon the different values of x, a line will be drawn based upon using it for it. Okay, so how did I draw this line? I check the value of this function based upon different values of x. So for x equals to 0, if I put x equal to 0 here, 7 into 0 becomes 0. That remains only 3. If I put x equals to 1, then 7 into 1 is 7. 7 plus 3 is 10. So the function of x value becomes 10. So that's how I'm saying. So when x is 0, the value is 3. So this is 0 comma 3. When x is 1, it is 1 comma 10 somewhere here. Or maybe up more above this thing, more above than this. Okay. So this is linear polynomial. Now let's say what we want to see is quadratic polynomial. So what is quadratic polynomial? So quadratic polynomials are the ones where we have the power of x as 2 as well. So if I say 4x square plus 3x plus 2. So if you see here, the power of the greatest power of x is 2. So linear is power 1, quadratic is power 2. Okay. So these powers that I'm writing, these are the maximum biggest powers that are present in this expression. This is also called a degree. Okay. So maybe I can write it here. So we are talking about different polynomials and we are writing the degree of it. So linear has degree 1, quadratic has degree 2. Similarly, if you see cubic means the power of x can be 3 as well. So 3x cubed plus 5x square plus 9x plus 7. So if you see the biggest power is 3, so the degree becomes 3 for cubic polynomial. And the next is biquadratic. So what are biquadratic? Where the power of x can be 4 as well. So let's say x to the power 4 plus 3x cubed plus 3x square plus 2x plus 7. So this is biquadratic. The highest value of x highest power of x in this polynomial is 4. So the degree of this polynomial also becomes 4. So this is one more thing that we have learned, that we can calculate the degree of the polynomials, right? And we can also plot the polynomials on the graph paper when using the different values of x and finding the value of fx based upon it. Okay, so this we have learned, and we have also learned what are the different polynomials that are present: linear, quadratic, cubic, biquadratic, etc. But there are some expressions which are not polynomials, like 2 upon root x. Okay, so I'll move ahead. So now we have seen quadratic expressions. So let me just write down an example. So here we are going to talk about quadratic polynomials. So how can I signify quadratic polynomial? Ax square plus bx plus c. So where a is not 0. Okay. So this is the expression for a quadratic polynomial. Now, if you see, one thing which is very important here to learn is, based upon value of a, the graph of the quadratic polynomial will change. So if a is greater than 0, then how will the graph will look like? The graph will always open with the mouth open towards up. If a is equals to 0, or a is less than 0, sorry, a is less than 0, in that case what it means is the graph will open its mouth towards down. Okay, so this is very important to understand. Now, based upon this, there are questions as well that we'll do in some time. So one more thing that is very important to understand is what is d here. Okay, so d is calculated based upon b square minus 4ac. So once we calculate the value of d, based upon d also we can tell how many roots this polynomial will have. Okay, so we know this is a quadratic polynomial, but so maximum it can have two roots, right? So now, but we are saying based upon d, we can tell whether it will have 2, 1 or 0 roots. Let's see how to do it. So if the value of d is uh, less than 0, then what happens is, let's start with positive. D is greater than 0. And we know a is greater than 0. So let's say d is greater than 0 and a is greater than 0. So since a is greater than 0, the mouse will open towards up, and therefore I can draw the graph like this. So it will uh, meet the axis on 2 points. So we will get 2 roots for this equation. Okay. Now let's say d is equals to 0 and a is still greater than 0, right? I am not going to change a. Now since d is 0, the root will be only 1, where it meets the x-axis. Okay. The last part, when d is less than 0 and a is still, let's say, greater than 0 only, in that case, what happens is, we have this x-axis, y-axis coordinates. The graph will be somewhere here. It won't even touch the x-axis. So that means we will not have will not have any roots. So it will have only 0 roots, no roots, you can say. Here, 1 root, and in the first example, it will be 2 roots. Okay, so this is very important to understand. Now, so this is one thing. So let's take an example and try to understand. Okay, so let's say we have 4x square plus 2x plus 3. So since coefficient of x square is 4, so that means a is greater than 0. Now let's calculate d as well. D is b square minus 4ac. So in this case, what does b square becomes? This d becomes. So d is b is 2 square minus 4 into 4 into 3. So it becomes 4, 16 is 48. So it becomes minus 44. And this is less than 0. A is greater than 0. So A is greater than 0 and D is less than 0. So in this case, based upon this, we'll say it does not have any roots at all. So there is no value of x where this graph will touch the x-axis. So you can also verify it. So if you say, because see, why we are saying this is because see, x is present here as well and in the x square as well. Okay. Now the thing is, if the value of x increase or decrease, it will increase or decrease the value of this x square as well, 4x square. And it will change more fastly as compared to 2x. So that's why for any value of x, this graph will not meet the x-axis. So there is no roots on this one. Okay. Let's go ahead and see the next graph or next question. Next point actually. So relationship between graph and ABC. So let's say that we have a graph, okay, uh, which is like this. Okay. So based upon this, what can you tell me? Like what are the values of ABC? So the equation is ax square plus bx plus c, right? This is our equation. Now we have to find the value of the signs of A, B, and C based upon this graph. So we have just now learned where is the face of this parabola opening. So this is parabola, right? Because this is a quadratic polynomial, the graph will be created as parabola. Uh, so where is the face of this graph opening? Towards up. So that means A is greater than 0. Correct? Now, the second thing is B. I want to see what is the value of B. So if you see here, okay, one more thing. So this point that you see here, this can be calculated using minus B upon 2A, comma minus G upon 4A. So this is the value of this particular point. This is the last point where, the lowest point for this graph. Okay. So now, since we are saying minus b upon 2 and minus g upon 4a, now let's see. A is greater than 0 here. Okay, so first let's understand what is the coordinate of x here. So coordinate of x is, since this is origin, right? This is origin. If we go left from here, the x value will be negative. If we go right from here, it will be x value will be positive. So we have a positive value of x. So we know minus b upon 2a is greater than 0. Now we know a is also greater than 0 based upon this. So this 2a also becomes positive. So that means minus b has to be greater than 0. That means the b should be negative. Then only the value of minus b will be greater than 0. So let's say b value is 2. In that case, this becomes minus 2. Minus b becomes minus 2. And then this is less than 0. This is not greater than 0. So the value of b should be negative. Let's say minus 5. In this case, minus 5 becomes 5. Therefore, the b value is less than 0. Now for the value of c, how do we calculate c? Now, if you understand, the function is ax square plus bx plus c, right? Now, I want to find the value of c. If I make this whole thing as x as 0, I'll get the value of c. I'll get the value of this function as c. For x equals to 0, fx becomes c, because this term also becomes 0 and this term also becomes 0. So what remains is fx is c. Now, in this graph that we have here, where is x equals to 0? On the origin, we have x equals to 0. Now, for this x equals to 0, what is the coefficient of, so what is the value of fx? If you see here, on the y-axis, where does this graph touch the y-axis? So it touches here, right? Now, since this is positive for y-axis and this is negative for y-axis, so that's why it is touching the positive part of y-axis. So that means C is also positive. Okay. Because if C is negative, in that case, the graph should have been, I mean, the graph should have touched y-axis somewhere here below the origin. Since it is touching above the origin, that means the C is positive. Because function is value of fx is C only, right? So that's the answer. So this is how we can find the coefficients sign of ABC. One thing that you have to remember is this particular thing that we have just now did, the lowest point or the highest point. So in this case, you can see the vertex of this graph will be at minus b upon 2a and minus d upon 4a. Okay, hope it's clear. Okay, okay, let's do one more question. Uh, so we have um 7x square plus 25x minus 2. So this is the polynomial in front of us. Now we want to understand how will the what are the coefficients of, sorry, what is the graph of this polynomial? How do we find it? So this is x and this is px value. Okay, it is the value of the function. So when x equals to 0, if I put x equals to 0, both of these terms become 0 because 25 any number into 0 becomes 0 only. So the value becomes minus 2 in this scenario. If I put 1, then it becomes 7 plus 25 is 32. 32 minus 2 is 30. So it will become 30 here, right? Now if I say I put minus 1, 7x square becomes 7 and this becomes minus 25. Minus 25 plus 2 is minus 27. Minus 27 and plus 7, that becomes minus 20. Okay. So, and we know that A here, which is, so I can also write this equation as ax square plus bx plus c. Now I know A is 7 here, right? So that means the graph will have its face open towards upside. Now, if you see at 0, the function value is minus 2. So let's say somewhere here, 0 comma minus 2. And at 1, so x is 1 here, it becomes 30. So let's say it becomes 30 here somewhere. And for minus 1, it becomes 20 somewhere here below, right? Minus 1 comma 20. So it is cutting x-axis for sure, right? Because these are three values which are coming. But let's check what is the value of d here, just to be sure. B square minus 4ac. So b is 25 here, right? So I'll do the square of 25. Minus 4 into 7 into minus 2. So what is the square of 25? 25 square is 625. And this becomes minus 28 into minus 2. So minus minus becomes plus 625 plus 28 into 2, 56. This becomes 675 plus 6, 681. Okay. Since it is positive, so that means for sure it cuts the x-axis. So if we try to put the value, or if we try to create the graph here, it should be somewhere like this. Okay. So this is how we plot the graphs. We calculate the value of function based upon different values of x. Okay. And then we plot the graph. And using D, we understand whether the graph will touch the x-axis or not. Whether it will touch only at one point or at 2 points or it won't even touch. So that information becomes clear based upon the value of t. Okay. So I think this is sufficient for one lecture. We'll cover the next part in the next lecture. Thank you.